Hello and welcome to another episode of the How to Create VR tutorial series, where you learn by watching other VR, AR, and MR professionals create the magic. I'm Marcelo Lewin, an immersive content specialist focused on e-learning and training. I'm also the creator and the guy behind howtocreatevr.com. My guest creator today is Shachar Weis, a software developer with over 20 years of experience in 3D platforms like Unity, OpenGL, DirectX, and many others. Today, Weis will give us an overview of 3D scanning and photogrammetry for creating virtual reality experiences. But before we get started, I want to remind you to register at howtocreatevr.com. It's free, and registration gives you access to all of our live events, tutorials, practice assets, podcast interviews, videos, and more. Just visit howtocreatevr.com and click on the Register for Free button. Finally, if you want to attend our live events in virtual reality, join us inside Altspace VR. Just visit howtocreatevr.com/AltspaceVR and subscribe to our channel. All right, Weis, welcome to the tutorial series.
Hello, Marcelo. I'm very happy to be here.
Nice to have you. I know I butchered your first name, so I'm going to give you a chance to actually say it for us, because I'm going to have to practice and get it right. So go ahead and say it for us.
Well, okay, so my first name is Shachar. It's pretty hard to pronounce for English speakers. It's Hebrew, and it means dawn, before sunrise.
Oh, I love that. And then your last name is Weis, and you go by Weis, right? So we'll just call you Weis.
I go by Weis. It's just easier.
Yeah. It's much easier. Yeah, exactly. All right, cool. Well, hey, welcome to the tutorial series. I'm glad to have you here. This is a topic that many of us is a mystery to understand. So you're here today to demystify, right? Photogrammetry and 3D scanning specifically for virtual reality.
Yes, I sure hope so.
Yeah, cool. Before we get into the presentation, we always love to learn about the presenters. Real quick, give us a quick background of your experience.
Sure. So I'm a software developer. I've been a technical person and a software guy for many, many years. Throughout my career, I've done a lot of interactive stuff, interactive software, projection systems, kind of reactions or things that react to movement and touch. So I've always been on the visual side of software. And I've also always been interested in photography, just capturing the world around us.
So you kind of mix both of them together.
Yeah, I just like to mix these two visual aspects and the software aspects.
So is that how you got into photogrammetry and 3D scanning? Was it just out of curiosity or was it a project?
Well, pretty much, yes. It started as a hobby. It was kind of a natural continuation of photography, which I was always interested in. I did a lot of panoramic photography, infrared photography, aerial stuff, and then eventually I discovered photogrammetry a few years ago, just dabbled around with that for fun, more or less, and it became more and more serious, and it's a big hobby of mine right now, professionally and on the leisure side, just scanning stuff.
It's a wonderful thing when you get to do what you enjoy for a living and call it a hobby and work.
At the same time, yes.
At the same time, yeah, definitely. So, and I know you're probably going to go into this later, but real quick, what's the difference between photogrammetry, when we talk about that, and volumetric video?
So there's a lot in common, actually. The mathematical underlying algorithms or the foundation is very similar. You can think of volumetric video as being an extension of photogrammetry in the same way that you take a lot of pictures and it becomes a movie or a video. So in a sense, volumetric video is many different slices of photogrammetry.
I see. Almost like photography is slices of a movie, right?
Exactly. So a photogrammetry scan would be one frame in a volumetric
video. So the principles are pretty similar.
They're very similar, yes.
They're just multiplied by 30, 60 frames, whatever it is.
By a lot? Yes.
Yeah, exactly. Okay. All right, Weis. Well, thank you so much. I'm going to let you get started on the presentation. And if I have any questions, I'll jump right in.
Sounds good. Let's go. So we're going to talk today about 3D scanning and specifically photogrammetry, but we're going to open a little bit with what is 3D scanning, how does it help me, and why is that something I want, especially in VR? So let's talk about game development for a second. There's a concept called hero or hero object in game development. And these are objects that are close to the screen or prominent or are important. The protagonist, the character that you control, some kind of item that you pick up, things that the user looks up closely at or controls directly. These are called hero objects, and these are usually modeled in high polygon and high fidelity, high resolution, high quality textures, and so on. The thing about VR, though, is that you lose this control you have over the user's perspective or the user's viewpoint. In VR, users wander all over the place. They will crouch and look under the table. They will walk around to the other wall, to the other side of the room, and they will poke at things and they will look at them. And if those items are crude or fake, then it breaks their immersion. And that's something you want to avoid. Immersion is key with VR experiences. You want to preserve it at all costs. So really, everything needs to be a hero model in VR. And that can be very time-consuming and difficult. And 3D scanning comes to the rescue. What is 3D scanning? 3D scanning is the process of taking a physical object, in this case, this little sculpture that I made a few years ago from clay, and converting it into a 3D model, which is a mesh and a texture. Combined together, you get an object that you can look at from all angles, you can do things with it in VR, and you can render it in all sorts of ways. Let's talk a little bit about 3D scanning versus other methods of creating stuff, 3D modeling, for example. Most of you will know what this means, sitting down with Blender or Maya or 3D Studio Max and creating a 3D model. This camera, one of my favorites, if you look at these models, they look pretty much the same, but the left one was hand-created in Blender, I believe, and it can take up to 20 hours for an experienced modeler to create something like this. The one on the right, I scanned from my collection of all cameras, and it took me about 20 minutes of work. Now, yes, the 3D modeled one is cleaner. It has nicer textures. It has parts that are shiny, parts that are matte, which is a bit difficult to do with 3D scanning. But it's an order or two of magnitude more time-consuming than 3D scanning stuff. And if this is a prop that is sitting on a shelf somewhere in a VR experience, then the 3D scan one is perfectly fine. And it's so much easier to do.
You mentioned that in 3D scanning, it's kind of hard to pick up matte versus shiny. And if you're going to go into this in later slides, we'll leave it for then. But can you touch upon that? Why is it hard? Just a quick overview of why.
So I am going to do it in later slides in a bit. It's hard because it confuses the software, and we'll talk about why in a second.
Got it. Okay, thank you.
And if we look at the underlying models, the one that's hand model is again cleaner than the 3D scan. But since the texture of 3D scanning is usually so good, it hides most of this messiness, and it looks perfectly fine. So to summarize 3D modeling versus 3D scanning, modeling is very accurate, it's clean, you can use multiple materials, and it's highly optimized. 3D scanning, on the other hand, is cheap because it's fast. You almost don't need any skills. Anybody can do it. You don't need to learn 3D modeling or texturing or unwrapping or stuff like that. So 3D modeling is also expensive and slow, and 3D scanning, the downside is that you need a physical copy, right? You cannot scan an object that you do not have. And also, not everything can be scanned. But if you have the object and it can be scanned, then it's a really nice way of getting it digitized very quickly.
Now, you mentioned that the scanning, obviously, it's not as clean as the 3D modeling, but can you, after you've completed the scan, can you clean it up in post?
You absolutely can, and we will touch on that as well.
Perfect.
So 3D scanning is also hard, not for you, but for the software. It's a difficult mathematical problem to solve, and it took many years until the algorithms evolved and got to the point where they are today, where they're pretty good. Scanning shiny reflective objects is problematic because it confuses the software. We'll touch about that a bit later. Objects that move are also problematic because you need to take many pictures, and again, we'll talk about that. Things that you cannot see, occlusion, and fuzziness in general, hair, fur, leaves, are all these things that are difficult to scan. Other than that, you can go crazy. You can scan mountains, houses, cars, pets, objects, cameras, anything you want. Now that we know what 3D scanning is good for and what it's not, let's talk about how to scan things and what's the process. Right, so there are many ways to 3D scan objects, and we're going to focus on one of them, which is called photogrammetry. And the reason we're focusing on photogrammetry, because it is by far the cheapest one. Most other scanning techniques require expensive equipment. 3D scanners can go into the tens of thousands of dollars for the hardware required. With photogrammetry, really all you need is a camera. You can use a good camera, you can use a decent camera, even a smartphone camera in some cases works perfectly fine. You need a bit of software and you're good to go. So let's talk about photogrammetry, how it's used, why it's good, and how to get good results. Photogrammetry, also called multiview geometry, that's kind of the mathematical name for this, is a process of reconstructing a 3D model from 2D images. You'll want to take a lot of images all around your object from all angles, and then a very sophisticated algorithm, which I will not go into, finds matching points and triangulates from that the 3D positions of the camera when it took that shot. Then does a lot more math, and the result is something called a point cloud, which is then kind of wrapped around and skinned to become a mesh. And then all those cameras are projected on the mesh to create a texture. Now that sounds really complicated, but it's not, at least not for the end user. And it's a lot of fun as well. So if you look at this 3D scan of my wife standing there on the grass, the little blue squares are where I took the pictures from. I basically walked around her as she stood there grumbling, kind of urging me to get this over with, and took a lot of pictures. And that was enough to create a 3D model.
Did you use a tripod?
So in this specific case, I did not. I just walked around.
You just walked around, yeah.
Handheld, yes, because I wanted to make it fast.
And the algorithm is smart enough to be able to figure out even the variances in position, I guess, from like height. You don't have to be like perfectly aligned.
You don't have to be perfectly aligned, no. And actually, sometimes you don't even want to be. And we'll talk about that in a second.
Cool.
So these are the shots that I use for this scan, or part of them. And again, photogrammetry is cheap, and you can get really good quality texture and mesh. And the nice thing about it is that anything you can take a picture of, you can scan. So you can scan things from a grain of sand to a mountain, as long as you can take enough pictures. The process can be slow. It doesn't work well with reflective surfaces, which, by the way, confuses most 3D scanners in the world. So it's not a unique thing for photogrammetry. It doesn't work well with features or surfaces that have no features to them. So if you have a wall that's absolutely clean and there's nothing on it, then there's nothing for the software to lock onto and triangulate, and it will fail on that surface. There's several ways to do photogrammetry as well. The high-end way is by having a lot of cameras. All of these cameras are connected and synced together to shoot a picture at exactly the same time. This is really high-quality stuff. It's instantaneous because all of these cameras work together. It's really the only way to scan living objects like humans, because we have a hard time not moving for 3 minutes or not breathing as well. And you can get really clean and beautiful results. The downside, obviously, it's that it's really, really expensive. Having 100 DSLR cameras is not something most of us have lying around. So we're not going to talk a lot about this, just know that it exists. Photogrammetry for the rest of us is using a single camera with a turntable or just walking, like I did in the previous example. And this is enough to get really, really nice results, especially if you have very messy or organic objects, like this sculpture or a piece of wood or a rock. Things that are actually very hard to model are easy to photogrammetry-rize. Again, the downside is that moving objects are difficult, and you have to be careful with lighting, which we will talk about in a second.
Do you recommend a turntable over walking around?
If the object is small and you have good control over the light, which I will talk about, then turntables is a very easy way because it saves you a lot of time. Before we go into the process of taking the pictures, I'm going to talk about the software and what's available on the market. Capturing Reality, Agisoft, Meshrooms are the big players. Capturing Reality is relatively new on the market. It's only a few years. It kind of disrupted the whole scene because it is really, really good. It's a subscription-based software, so it's $30 a month, which is not cheap. It kind of adds up really quickly. It's really fast and also a bit buggy, but it is, from my testing, the best on the market right now. For many years, I used Agisoft, which is a lot cheaper if you take into account how long you have been using it. It's a fixed license at $180 for a lifetime. And it's kind of old school UX, but it does the job. It produces good results, but it is significantly slower than Capture Reality. It can take hours compared. It's about 4 to 5 times slower. So if a scan takes an hour in Capture Reality, Agisoft might take 4 or 5 hours. There's also something called Meshroom, which is relatively new. It's open source and it's free. It's a bit hard to use. As many open source projects, the user interface side is a bit lacking. You can play around with it. There's something called 3ds Sapphire, which is nice because it's free for less than 50 images. That's a bit not enough. It's a bit low number for photogrammetry, but you can still get pretty decent results, and it's the only free options that I know of.
If, let's say, you're just starting out and you want to understand the workflow of photogrammetry, would you recommend 3D Zephyr just to play with it, or?
I would actually start with the trial version of Agisoft, which I believe is either 1 or 3 months, I don't remember, of a free trial that gives you full functionality.
Got it.
Yeah. So in this specific lecture or talk, I'm going to demonstrate with Capturing Reality, but the process is the same for all of these. The phases that you go through are the same, and especially important, the requirements from the photography part is the same. And really, that's the most important part, is the photography. So let's talk about that now. So a quality 3D scan starts and ends with good pictures. That's really what makes or breaks the scan, is shooting pictures and shooting them in a way that's beneficial for the scanning. And I'm going to say this now, I'm going to say it again later. You have to remember that your goal is a good scan and not necessarily nice looking photographs. Right, so if you're a photographer, you kind of have to switch a little switch in your mind, in your brain, that you're not shooting to create nice photographs or nice pictures. You're shooting to create pictures that will result in a good scan, and they're not exactly the same thing. So let's talk about the photography part. A good camera helps a lot. You want to shoot manual, exposure, aperture, white balance, pretty much anything you can. So the pictures have less variance to them or are as uniform as possible. You want to shoot with a wide depth of field. That means closing your aperture. So everything is as sharp as possible. And again, this is kind of goes against your natural instinct as a photographer in some cases, where a shallow depth of field or a blurry background kind of makes the picture more appealing. It makes the object pop. For photogrammetry, for 3D scanning, you want everything as sharp as possible. This is just a little explanation of what depth of field is. If you don't know, it's an area where everything is in focus, and before and after this volume, everything is out of focus. So when you close your aperture, you make this area bigger, and that's your goal. So just close the aperture as much as you can, considering the light in the scene.
Quick question on that. If, let's say, for example, you're shooting outside and it's too bright, and you want to use an ND filter, right, so that way you can still close it, will that affect your scan?
So if you're shooting outside and it's bright, it's actually working in your advantage, because you can close the aperture without losing shutter speed and without getting blur.
Got it. So the shutter speed you want to keep consistent.
Fast. You want to keep it consistent, and you also want to keep it fast enough so you don't get any motion blur.
Right. Okay.
Right. Any kind of blur, either from motion or from focus, is bad. Lighting is very important. And again, you want flat lighting. And this is not necessarily the best looking picture, but it will result in the best looking scan. So in this example, we're seeing 3 rocks, which I shot outside on a sunny day, and I waited for a cloud to roll in. The left picture is full sunlight. It has very sharp shadows and a big contrast between dark and bright image areas. And this is bad. You don't want this. The middle image is okay. The right image is the best. So you want lighting to be very uniform, very soft, and very flat in general. I mentioned this before, I will mention this again. Motion blur is bad. You want to avoid it as much as possible, so you want a high shutter speed. You will want to walk around your object and shoot about 50 to 60 pictures per full rotation. And you want to do at least 2 heights, preferably 3 or even 4. And try to keep the distance more or less constant from your object, and shoot raw if you can. And we'll talk about that in a second. This is a little clever diagram I have here where explaining how to walk around an object. It's very complicated walking. And usually I take 3 sets of pictures, one from just above my head, one from more or less eye level, and one from kind of waist height, all pointing at the center, at the object I'm taking pictures of or trying to scan, and walking around this object. So if I do handheld scans like this, I usually shoot between 150 to 180 pictures. In three cycles, 3 circles around the object.
So you're not shooting the 3 heights at the same time, then move to the right and shoot 3 heights at the same time. You're shooting 1 height, go all the way around, then you start again at a different height and go all the way around and do that 3 times.
Correct.
Got it.
However, there's not really a requirement. If it's easier for you for whatever reason to do 3 heights and then step and do another 3 heights, that's also fine. The software will not care.
But when you're, or maybe you're going to cover this later, but when you're bringing it all into post to do the stitching and everything you need to do you have to like name them, this is height 1, this is height 2, this is height 3? No, it doesn't matter. Okay.
No, it doesn't matter.
The algorithm figures it all out for you.
It figures it out for you, and it doesn't matter. Just do what's easier for you. For me, it's easier to do 3 circles, 3 cycles, keep the same height, and just change height 1, 2, 3 times. But if you find it easier to do the other way, do it. It's up to you.
Yeah, that makes sense. Cool, thanks.
Let's talk about how to shoot pictures, and walking is obviously the easiest one. There's really not much to talk about that. You walk around the object and you take pictures. You can fly if you have a drone, for example. Some drones have a circle target or an orbit function. And again, same idea, you fly around the object and you shoot it from different angles, from different heights. I'm just going to say that in most cases you need a permit to do this stuff, so don't forget about that. And this example that came up here, this is my house, and I did not have that function in my quadcopter. This was many years ago. So I just flew it manually, more or less. You can see it's a bit messy. And I did 3D scan my house like this with a drone. And this is the drone in question. It was hand built and it's a mess.
And you shot photography, not video.
I shot photography, not video, correct.
Now, question for you on that. Is there a way to shoot video and then just randomly pick frames from the video? Would that make it any easier or not really?
So that is an excellent question. You can shoot video and then you can extract frames. However, it will always be of a lesser quality than shooting stills.
Right, because you're shooting 4K or 1080.
The resolution is lower. Right. You have compression artifacts.
That makes sense.
All sorts of things that reduce the quality of the image.
Right. So RAW is the best, or at least super high resolution of photography is better.
But in some cases, video works, and you need to experiment. Like, it's a lot easier to shoot video.
Right.
So it's definitely worth a shot. So let's talk about photogrammetry in the studio. The best way to do this is with a turntable, or some places call it the lazy Susan for some reason. And on this turntable, you want to put something that is textured, so the software can lock onto it. And you want flat lighting. Again, this is super important. In this case, I found a little closet in my basement where if I put a LED light pointing at the ceiling, I get really soft and really uniform lighting. This is where I do most of my scans. And you can see this is a very messy setup I built here. It has a little wheel that I took from a Lego set, a stepper motor, an Arduino to control it, and it triggers the camera, and it just does the whole process automatically. So one full rotation, 50 shots per rotation, and I don't have to do anything. It just does the whole thing. And then I move the camera up or down, and I do the whole thing 3 times. You can build this thing for less than $50. If you want to, actually the instructions are on my blog. You can check it out later. There are products on the market that do this, not many, and they're expensive. And building it is honestly a fun experience, and if you've ever done anything even remotely like this, it's a few hours of work.
But the reality is you truly could just take that turntable and just move it yourself with your hand, right? And you just have to do that 50 times.
You absolutely can, and many people do, and just move it with your hand,
right.
Shoot the camera, press either with a remote or a cable, or just press the button and repeat the process.
Because it doesn't have to be exact. So that was my point. I mean, obviously this is a better setup because it's automatic, but it doesn't have to be exact where you're moving it exactly, 10 millimeters each time.
Correct. It does not have to be exact.
Right. Okay.
You can see here that I've kind of made markers, but then I found out later that it's not really required, so you can ignore those. Oh, let's see this thing in action. It's very exciting. Now that you've shot your pictures, there is post-processing that you should do on the pictures themselves, on the photographs themselves, especially if you shot RAW, and you really should shoot RAW if you have that option. The nice thing about RAW is it gives you a little bit of play with regarding to exposure. So you want to make the image even flatter than it is already. So you want to pull down the highlights and bring up the shadows. And you can do this in most RAW editing tools. In Lightroom, it's pretty easy to do. You want to remove noise. What you do not want to do, and I actually did this for a long time before I figured out that's a mistake, is you do not want to apply any lens correction. So every lens has a bit of distortion to it, and most of these software suites have an option to remove the distortion based on lens parameters or calibration. Don't do that. You want to keep that distortion in there. And I know what you're going to ask. Why? Is because by doing that, you mess up the pixels, or basically you move things around in the image, and it actually makes it harder for the photogrammetry software to triangulate.
That makes sense. And you're right. I was about to ask that.
Yeah, there you go. Now that we have all our pictures, we can talk about the software part of the scanning. And for this example, I'm going to use RealityCapture. But again, I will say that the process is very similar to other photogrammetry software. There's a few steps involved, and they're pretty much identical. The user interface is different, but I'm pretty sure you'll figure it out. The first thing you need to do, or the software needs to do, is alignment. This is the process of taking all the pictures that you shot and figuring out where in space they were taken from. And with RealityCapture, it looks like this after you actually align the images. So the first thing you want to do is just drag all the images into the software and hit this button here, which says Align Images. And this will take a few minutes. This will take 5, 10, 20 minutes, depending on how many pictures you have. If you have 200 or less, it should not take more than 10 minutes. If you have 1,000 pictures, it could take a while. After you've done this, in RealityCapture, you'll have something called a component, which will appear right here. And this component will have all the images in it. And if you have more than one component, that's not great. It means that it could not align all of them. It could only align them in chunks, and it doesn't really know how those chunks relate to each other. If you took a lot of pictures and you were careful about taking pictures from all angles, you should have just one component 0, and then you should be happy about that. If you have more than one component, then you either need to reshoot or just ignore the components that have only a few images to them. If you have a lot of components, then you have to probably redo the whole thing. After you align your images, you want to tell the software which part exactly is the interesting part, because it will show you everything that was scanned. It will show you if you did this outside, it will scan the entire neighborhood. Everything that was visible inside of the camera pictures will show up here. And you probably don't want all of that. You just want one specific thing, one small object. And this is the part where you tell the software which object you're interested in, which area you're interested in. In RealityCapture, this is called reconstruction region. You'll want to set your view to parallel. You do this in the scene tab right here. And this changes the view. Working in a perspective is a bit annoying. In parallel, it's a lot easier to accurately set that region. And you'll want to set it to the smallest thing that you can, and while keeping everything, all parts of your object inside this area. The smaller this area is, the faster the reconstruction will be, and you don't want to waste processing time on stuff you do. You can rotate this region, and you can move the object around. You just have to go and play with the user interface a bit. It's really not that difficult. After you set the region, you're ready for the next phase, which is creating a mesh or a 3D model. It should come out like this, nice and clean. No texture at this point. It's going to be either white or gray, and it's going to be the vertex count or the resolution of the 3D model will depend on the megapixel count of your camera. So the higher the megapixel count on your camera, the more detailed or more polygons you're going to get in the 3D model.
Now, question for you on, because you had this guy on a turntable, right? Or let's pretend you had him on a turntable.
Oh, yeah, he definitely was on the turntable.
Right, okay. So when you when you define the area that you only want to bring attention to, right? The turntable is still there because you can't get rid of it fully. And you're not really drawing a mask like, let's say you do in Photoshop, right? Where you can be very precise on the mask and this is it. So how does it figure out that the turntable isn't really part of this guy?
So in this case, I actually used a little buffer here. I put this guy on a little piece of foam to make him float above the turntable, right? And you can see this brown splotch here. That is the turntable. And I set my region of interest, I set the region here to not include it.
I see. So from a production perspective, it's important that when you place your object or even people, that you don't have anything next to that person. So you need to consider what's going to be this region of interest during production. So in post, you don't have a problem. Like during this portion, you don't have a problem. And for example, let's say there was a glass right behind this object. That would the software would consider it part of the object or part of the component, yes. Right? Yes. So in production, it seems like it's really important to understand the post process and understand how to set up that person with enough buffer so you can regionalize them, right?
Yes, the person or the object. It's usually best to have a clean area around it.
Right. Okay.
Right. However, if you don't have control over this, you can actually remove parts from the mesh, which we'll get to in a second.
Okay. Cool.
So it's best to do it in advance, but if you absolutely can't, then don't worry about it. You can clean it up after, and we'll get to that in a second. So after you do the meshing, you'll get something like this. The vertex count will depend on the megapixel count. Processing time will depend on your GPU. In case of RealityCapture, it runs on the GPU. It can take minutes, it can take hours, again, depending on the quality of your images and how many images are there in the dataset.
Do you recommend a specific GPU, like a GTX 1080 or above? Or
the better the GPU, the faster it's going to scan. Okay. I personally have a 1070, a GTX 1070, and it's good enough for most of the stuff I do.
Got it. Okay.
Right. In this presentation, I'm only talking about scanning objects. And with object scanning, you need a few hundred pictures at most to get good results. Like 200 is good, 500, you're going to get really nice results. If you're scanning an environment, like a room or a building, you're going to need many thousands of pictures, right? And we're not going to talk about this at this presentation. Maybe we'll do another one at some point. When it gets to that, thousands of images, then the processing time can take hours, days, right? So then it really matters what kind of hardware you have on your computer. Now you have an option of cleanup or post-processing the mesh. You can delete unwanted parts, you can close holes, and you can make it smaller, which is also important. You can do this in RealityCapture or in Agisoft or in whatever photogrammetry software you use. Most of them have some tools for cleanup. But you can also use external software like Blender or 3D Studio Max if you're comfortable with that, or Maya, whatever you know or want to use. In this case, I'm going to show how I deleted this bottom part, which is a big pinkish in this model, because that's where the piece of foam was that held up this little sculpture. And I didn't want this in the scan. So in reality capture, you can just have one of the tools is just selecting the vertices or selecting part of the mesh that you don't want. After you select it, it becomes kind of orange. You just delete it, and then you run another function called close holes, and you get nice flat bottom, which is what I wanted here. The issue you brought up, what if there's another object that's close to this one, and I could not separate them because I didn't have control over this? This is the point where you can actually select that object, either with a lasso tool or with a rectangle. It has several options for that in reality capture. You select that object and you just delete it, and it's gone.
Do you recommend doing that, let's say, probably the answer is no, but in Photoshop?
If you do it in Photoshop, you have to do it for every single image, which is a pain. There's really no reason.
Okay.
Again, you can export the model and then use any kind of software to clean it up and bring it back into reality capture or into Agisoft and continue the process. Another important thing in this post-processing is simplifying. Usually you get an object that has a really high polygon count, and you don't want that much, especially not if it's not that detailed. Like this sculpture, it doesn't have a lot of tiny details on it. You can use the built-in tools, which are perfectly fine to simplify. I mostly use the Reality Capture Simplify tool, which is built right into the software. But you can also use something like Instant Meshes or MeshLab or other tools. This example uses instant meshes. What's nice about instant meshes is that it's free, it's open source, and it converts your model into something called quads, which I'm not going to go into at this lecture, but quads are nicer than triangles, which is usually the output of photogrammetry. They're nicer because they're easier to work with manually. So if you have an object that you then intend on animating or rigging or making a skeleton or adding stuff, usually people convert it into quads before they do anything. And Instant Mesh does that freely and pretty nicely. And once it's been quadified or turned into a quad-based 3D model, you bring it back into Reality Capture or back into Agisoft and you continue with the process. And the continuation of the process is the texturing part. I'm going to do a quick slide on MeshLab because it's something I really like. It's free, it's open source, and it has a lot of very interesting functions in it to do hole closing, smoothing, decimating, subdivisions. Again, play around with it. It's definitely worth it. I mentioned this before, and texturing is the final part of the process where you take your object that was simplified or cleaned either in MeshLab or inside the software itself, and you build a texture. You will want to use a resolution of 4K or 8K because why not? Right? We're doing this to get high quality models, and they will look good if it has a 4K texture on it. You can always reduce that later, right? So I would say I do everything on 8K. This part of the process is going to take 5 to 20 minutes, depending on how many pictures you have. And you should get an object, if everything was done right, that looks really, really nice and very similar to your physical object.
And the texture can be added within Reality Capture.
This is the process that Reality Capture does, or Agisoft does. It creates a texture for you. It's an important part of the process. It's texturing. The texture usually looks like this. It's a bit of a mess. If you compare this to handmade 3D models that was made by a person, in those cases the textures is a lot more neat and it's kind of easier to figure out where different parts are. Textures that were created by photogrammetry software are usually very, very messy. They have a billion little tiny pieces. You can see the little pieces here. But you can still edit this. You can open this in Photoshop, and I often do this after the photogrammetry software created the texture. I put it in Photoshop and I just bring up the levels, I tweak the colors to get it what I want, I enhance the contrast a bit, you can even run sharpen filters. And you can also remove stuff if there are scratches or blots or something that you want to fix. You can use the clone tool in Photoshop and just edit this texture like you would any photograph, and it will update on the model itself.
Is there a trick to understanding the texture here? For example, the upper left quadrant is always going to be your top left,
No, there's no guideline like that.
Got it.
It could be anywhere. This falls into a very, very complex topic that's called UV mapping, which we will not go into because it could be several lectures just on that. But if you want to learn more about this, look up UV mapping or unwrapping. It's also called unwrap, and look at tutorials there. It's a very, very complicated topic, and it's basically how the texture gets applied or gets wrapped on the model.
Well, this just means that we're going to have to bring you back to do a whole bunch of more tutorials.
Well, I hope so. This is right. But the takeaway here is that you can edit the texture and just do whatever you want here. Managing seams is sometimes tricky because it's hard to tell where they are because it's such a messy texture, but it's doable. In this case, I closed up the bottom hole just by using the clone tool and just painting over all those black splotches in Photoshop. The last thing I want to talk about is something called normal maps. And again, this is just a little preview of this future lecture that maybe we'll do because it's a very big topic and very complex topic. And normal maps is a way of taking detail from a high polygon mesh and faking it on a low polygon mesh so it looks much better, but still doesn't really have those polygons on it. Normal maps look like this. They're usually pink or green. They look weird. You don't make them manually. There's different software tools to make them. And I'm not going to go into a lot of detail, but it's something that 3D modelers know. And it's a way of reducing the polygon count even further without losing detail.
And just to clarify, the reason to have low polygon count is so that way you can optimize your game or VR experience, right?
Yes, the render cycle is faster, you get higher frame rates, and you can run on lower end computers or on mobile headsets and stuff like that. Optimizing is very important.
Of course, all that may change in a couple of years or even much sooner than that when we get foveated rendering and eye tracking, which is coming out with the Vive Eye Pro.
Yes, so eye tracking will help a lot.
Right.
But you can argue that you will always need this because then you will want to push it even further. Right? You always want to maximize the hardware to get the most results out of the hardware.
Optimizing is always good.
Optimizing is always good. And there always will be. Another type of map is called Ambient Occlusion map. And again, I'm not going to go a lot into detail. There are tools to do this. Think about this as a way of enhancing contrast in a 3D model. You add little shadows or little darkness spots inside the nooks and crannies. It just makes everything look better. If you want to play around with these maps, I suggest something called X Normals. It's free software. It's a bit clunky. It looks like it has a user interface that was designed for Windows 95, but it works and it's free. So just give it a spin. And just a few little examples to close up things. I was hiking somewhere and I found this boulder and I decided to 3D scan it because it would look perfect as an asteroid. And the gimmick here, and I do this when I do this talk physically, I whip up this, take out this little boulder, and it's actually a fossil. It's the size of my fingernail. I scanned it with a macro lens, and it looks pretty impressive as a giant asteroid.
And how did you put it on a turntable, or?
Yep, it's the same turntable you saw before. I just put it right in the center. Yep. Yeah, and I use a macro lens to take a bunch of pictures. And again, anything you can take pictures of, you can scan. That's the beauty of photogrammetry.
And how did you grab it so it stays in the center? Like, did you use a little pin or something at the bottom of it, or?
Yeah, I use a little bit of clay to hold it.
Oh, I see. That's great.
At the center,
yes. Makes sense.
So a few more examples of stuff that I've scanned. This is very recent. This is an amp meter that was hand-built by a veteran during World War II when they didn't have any tools available. So he needed an amp meter, so he just built it from junk. My coins, sculpture from the local museum, my cat, and also myself. Again, go crazy, scan everything. That's kind of the fun part of this. All you need is a camera and a pair of legs or a turntable, and just go out there and scan stuff.
The scan of yourself, you stayed in that position for the 150 shots or whatever?
Pretty much, yes.
Yeah.
Yes. And if you go zoom into that, it's a bit blurry because not breathing is difficult. But it worked. Yeah, it worked. You can recognize me.
Yeah.
And it's pretty fun. One more fun thing this is a very recent hobby of mine is found footage scanning. So what I did is I just searched for Petra. This is in Jordan. It's called the Red Rock or Petra. It's a very famous and very old structure. And there's a lot of pictures of it on Google Images, just pictures taken by people who visited. Totally random pictures taken at different times by different people using different cameras from different angles. So I collected about 200 of these, and I just cleaned them up. I deleted the ones that were bad, and I fed them into RealityCapture. And with a bit of tweaking, you can get a 3D scan of something without even being there, which I find pretty fun. Another option is, as you mentioned before, is extracting frames from random drone footage that I found on YouTube and processing a 3D scan from that. So I call this found footage scanning, and it's kind of a pastime hobby. Yeah, that wraps it up.
Weis, thank you so much for doing this great presentation. I really appreciate it. I appreciate you sharing the knowledge with all of us, and I feel like we all have a much better understanding now of photogrammetry. So thank you so much.
You're very welcome. It was my pleasure.
Now, if people want to get a hold of you, what can they do?
So there's a contact form on my website or just an email. It's packet39.com. That's PACKET and the number 3 and the number 9.com.
I see. And we'll put it on our show notes as well. So thank you so much, Weis. I really appreciate it. And I'm glad the rest of you were here with us. Just a quick reminder, if you want to access all of our live events, tutorials, practice assets, podcast interviews, videos, and more, register for free at howtocreatevr.com. Finally, if you want to attend our live events in virtual reality, join us inside Altspace VR. Just visit howtocreatevr.com/AltspaceVR and subscribe to our channel. So until the next episode, I'm Marcelo Lewin. Cheers, everyone.